Hello everyone, back with the lecture series of microprocessor and microcontroller. And in today's session, we are going to discuss about pin diagram of microprocessor 8085, which is a continuation of unit 2 only. Right now, in last two sessions, we have discussed about the architecture of microprocessor 8085. Right, and in that we have discussed 5 different control groups in architecture 8085. And in today's session, we are going to discuss about the pin diagram of microprocessor 8085. Right, so the topics to be covered in the following session will be 8085 pin diagram, then its pin descriptions, right, and various types of pins. In this we are going to discuss about 2 types of pins, that is address and data buses, right, and status and control signals. Right, so here you can see this is a pin diagram of 8085. So 8085 is a 40 pin IC, right? So this you can see here, it is a 40 pin IC where starting from the leftmost side, the leftmost on the top of the there will be a 20 pins in continuation 1 to 20, and the rightmost type from the bottom to the top it will have a 21 to 40 pins, right? So whenever you are drawing the pin diagram, make sure you will draw like this way only, right? 1 to 20 pins, 1 to 20 pins from the leftmost side from the top to bottom, and in the rightmost side from bottom to top you will draw 21 to 40 pins. Right, now in this, you as you can see, first and second pin there are x1 and x2. So an x1 and x2 will stands for crystal oscillator. So crystal oscillator will generate a frequency on which 8085 is working. Clear, right? So as we have discussed in the feature of 8085, that the 8085 clock frequency is 3 megahertz, right? So in between x1 and x2 there will be a parallel combinations of capacitor, so we will generate 6 megahertz total frequency, and then it will be divided between among these two, x1 and x2. Right, now the third pin as you can see is the outer pin, right? So output pin having a name that is called as reset out, right? So we will discuss each and every function in detail, right? Then fourth pin, that is again an outward pin, which is SOD, that is for serial output data, for serial communication. Fifth pin, that is inward pin, that is SID, serial input data, right? From 6th onwards, 6 to 11, it is an interrupt pin, right? So 6, 7, 8, 9, there are 4 vector interrupts, which is trap, 7.5, 6.5 and 5.5. They are alternately outward and inward pins, right? And 10 and 11, they are non-vector interrupt, where 10 is the inward pin, which is with the interrupt request INTR pin, and the interrupt request will give the processor will give the acknowledgement on 11 number pin, which is INTA, that is interrupt acknowledgement, right? From 12 to 19, it is multiplex address and data bus. So lower order address bus from A0 to A7 and data bus D0 to D7 will be multiplexed here. And the reason behind that is to reduce the number of pins. We have multiplexed this particular address and data bus, right? And in last 20 number pin, it is a VSS. So this VSS is for ground. Clear? So this 20 number pin will be connected with the ground. Now moving forward to the rightmost part from the bottom to the top, as you can see from pin 21 to 28, it is A8 to A15, which is higher order address, right? Now 29 is SO and 33 is S1. So that is 2 status signals are there, which shows the status of the processor by S0 and S1 pin at pin 29 and at pin 33, right? After that, at pin 30 and pin 31, it is write bar and read bar, right? So write bar and read bar, what will it do? It will be the read from the processor and write to the processor, right? So these are the pins for read and write. When we are using a memory interfacing or IO interfacing, we are using this 2 pins, right? Then 32 number pin, that is VPP, right? So that is nothing but the reset pin. Clear? Then halt pin. Clear? Then next that is 34, that is IO/M1. So whenever we are going to interface the processor, we will have an option if we want to connect as a IO interface or as a memory interface. If we want to connect as a memory interface, then this pin should be 0, as it is having a bar over it. And if it is not having a bar, then this pin will be work as 1. Right? Then this 35 number pin, that is ready. It says that the processor is ready for the next task. Right? Then 36 number pin, that is reset in bar. So what does the reset in bar do? So reset in will reset the whole processor activities and will terminate all the activities, and the program counter will be at the address 0000H. Right? Then 37 will have a clock out pin, right, to send these timing signals for synchronization purpose with the help of other peripherals. Then 39 and 38, that is direct memory address pins, that is hold, and after holding the process, the processor will give the acknowledgement on 38 number pin, which is HLDA, that is hold acknowledgement. And last, that is 40 number pin, which is VCC, that is used for power supply to switch on this IC 8085, and it needs a plus 5 volt power supply. Right? So here in the left side, you will see the pin configuration of 8085, and similarly, how does the pin work, that will be seen on the right side of the diagram, which is called as functional pin diagram. Right? So this both pin diagrams you need to draw in the exam. Clear? Now, going forward to 8085 pin description, right? So the 8085 is an 8-bit general purpose microprocessor that can address 64 kilobyte of memory. So as we have discussed in features of 8085, that means if 8085 is a 8-bit microprocessor, so it can access 8-bit data simultaneously, right? And it has 16-bit address, so it will address up to 2 raised to 16, which will be equal to 64 KB of memory. It has a 40 pins, and it uses plus 5 volt for power, and it can run at a maximum frequency of 3 megahertz. So we need to generate 6 megahertz for between x1 and x2, and it will divide it between 3 megahertz. And this particular pins is grouped into 6 groups. Now these are defined as address bus and data bus, status signal control signals, interrupt signals, power supply and clock signals, reset signal, DMA request signal, serial IO signal, and externally initiator signal. So this all pins with the pin numbers and their functions will be seen in detail in today's session and in the next session. So in today's session, we are going to discuss about address bus and data bus, and control signals and data signals, right? So now going forward to next first type of pins, that is address bus and data bus. So as we have seen in pin diagram, that pin from 21 to 28, it is a higher order address bus from A8 to A15. So that is a 16-bit address line A0 to A15. But the higher order address bus, that is the address bus has 8 single lines, that is A8 to A15, which are unidirectional, right? And other 8 address, that is A0 to A7, are multiplexed with the 8 data bits, right? So this is about address bus. Now, as you can see in the following figure, that this is a whole 16-bit address bus from A0 to A15. In which A0 to A7, it is multiplexed with the data bus, that is D0 to D7, right, which is a lower order address bus, and data bus are multiplexed. And from A8 to A15, that is the higher order address bus. Clear? Now, next going forward to, that is data bus. Data bus will have a pin from 12 to 19. So it will have a bidirectional pin, right, as the data can be transferred from processor to peripherals and peripherals to processors, right, and it is multiplexed with AD0 to AD7 with lower order address bus, right, and this can be demultiplexed using an IC when at the time of interface. Clear? So during the execution of an instruction, these line carries the address bit during the early T1 state. Right, the first when the instruction is executed, it will take the address from A0 to A7 here and A8 to A15 from the higher order address bus. And after execution of instruction, whenever there will be a execution of data, at that time this lower order address bus will work as a data bus. Now moving forward, next that is status signals, right? So there are three status pins. First that is ALE, second that is S1, and third that is SO. Now ALE stands for address latch enable, that is pin 30, right? So when does the address latch enable use? So whenever we want to, we have a multiplex higher order, lower order address bus and data bus. So whenever we want to demultiplex that address and data bus, we need to enable this ALE signal. So whenever we enable this ALE signal, this will work as a lower order address bus. And when ALE will be 0, it will indicate that it will be the data will be, the contents will be are of data. Here, this signal can be used to enable a latch to save the address bits from the AD lines. Second, that is S1 and S0, that is status signal from pin 33 and pin 29. So as we have seen in pin diagram, that there are two status signal S0 and S1, and it shows the processor in which kind of operation is being performed right now in this particular processor, right? And it is usually used in small systems, right? So the following table shows about the signal status signals. So there are two signals, S0 and S1. So it will have a combination of two. So it will have a combination of 00, 01, 10 and 11. So 00 stands for halt. That means the processor is in a halt condition. If it is a 01 combination, then the processor will in a write condition, means something is written or something data has been transmitted from the processor to the peripherals, right? If it is 10, then it will be a read cycle. That means the data can be received by the processor from the input device or memory. And if it is a 11, then the instruction right now the instruction is going to be fetched, right? So during with the help of this table, we can find out that what in which process does the microprocessor right now it is carrying out. Now next, moving forward to this control signals. So control signals will have a three pins such as RD, that is read, WR, that is write, and IO/M bar, right, where M is an active low pin, right? So now what does this means? RD, that is read, which is again an active low pin. So it will gets activated when we will give 0 on that particular pin, right? So that it is a pin number 32, right? So what does the read mean? So read memory or IO device. That means the data is getting read from the memory or the IO device. Indicates that the data is to be read either from memory or IO device, and the data bus is ready for accepting data from the memory or IO device. So whenever we need to read the data from memory or IO device, right, we are using this read pin and we are activating by using 0 giving on that pin here, as it is an active low pin. Second, that is write pin, which is again an active low pin, and it is the pin number 31. So what does it do? Write memory or the IO device. That means it indicates the data on the data bus are to be written into a selected memory or IO device, right? That means the processor is transmitting the data to the memory or IO device in which the address has been given, right? And again, this pin will be activated when the 0 will be given, as it is a active low pin, right? And last, that is IO/M bar, that is input output and memory, and memory is the active low, whereas input output is the active high. So whenever IO/M bar equal to 1, then the address will be addressed to IO device. And if IO/M bar is equal to 0, at that time memory will be activated, so the address will be fetched from the memory. right? So it shows that how read and write operations need to be done, whether to memory or IO device. Clear? Now, in this next table, we can see that how from the memory or IO can be read or write, right? So here it is 0, 0, that means M is active, memory is active. RD, again RD and write bar, that is active low pin. So whenever there will be a 0, that pin will be activated. So RD will have 0, so this is activated pin, and write is 1, so it is a non-activated pin. So here memory is selected and here a read is selected. So the control signals will be MEMR, that is memory read. Clear? And the operation will be MEM read, that is memory read. Then again 0 is selected, so memory is selected. RD is 1, so it is not selected, and write is 0, so it is selected. So it will be MEMW, memory write. Clear? Then next, that is 1, 0, 1. So 1, that is IO is selected, RD is 0, so RD will be selected, and write is 1, so R write will not be selected, so it will be IO read, right? And whenever it is 1, 1, 0, then IO is selected and write is selected, so it will be a IOW, that is IO write, right? Now, whenever we combine this control and status signal, we get this following table, right? Now, in this following table, as you can see, there are three status signals, which is IO/M bar, S1 and S0. So on the basis of this, there will be a 8 combinations, right? And basis of this, there will be a operation. So whenever it will be a 0, 1, 1, it will be a opcode fetch operation. And whenever that will be a fetch operation, read will be 0, as we need to read the particular instruction. Now, whenever it will be 0, 1, 0, it will be a memory read, as memory is selected, right? So it will, when RD is 0 again. 0, 0, 0, 1, so memory write, then write bar is 0 and RD is 1. Similarly, 1, 1, 0, then IO read, again RD is 0, 1, 0, 1, IO write, then write bar is 0, then 1, 1, 0, it gives for interrupt acknowledgement, that is INTA 0, right? Whenever there will be a external interrupt, right, from the user, the processor will give acknowledgement in terms of this format 110, which is for interrupt acknowledgement, in which the INTA will be equal to 0, right? And last three, in which there will be a set. So in IO/M bar there will be a set, so it is a tri-state condition. Tri-state, that means right now it is in a buffer zone, so it is not working, right? Then 0, 0, and then status signal is 0, 0, so it means halt, as we have discussed in status table, right? And if it is don't care, so don't care will have a hold or reset. In these conditions, the read and write bar will be in tri-state conditions, so no data will be transferred to any device, and INTA will be 1, so there will be a no interrupt acknowledgement. Clear? Now, so in this session we have discussed about address buses, control bus, data bus, and status signals, right? Now in next session we will discuss rest of the pins, right? So that's all for today's session.